Today we're going to talk about CCM6 box plots. Box plots are also known as box and whisker plots. To know how to construct a box plot, you really need to know all of this material. If you're not familiar with the 5-number summary and all of these items, you can watch a video called the 5-number summary to get you up to speed. But for now, we need to know the 5-number summary, which is the minimum, the lower quartile, the median, the upper quartile, and the maximum values for a set of data. We need to know the lower extreme, which is also called the minimum. That's the lowest value in a data set. We need to know the lower quartile, also called the first quartile. That's the median of all the data values lower than the original median. We need to know what the median is, which is the number that's the midpoint of the data set. The upper quartile, also called the third quartile, is the median of all the data values higher than their original median. The upper extreme, which is also called the maximum, that's the highest value in a data set. Sometimes we use the interquartile range, which is called the IQR, and that's the difference between the first and third quartiles. If you need a second to jot this down, just press pause on your video and write all these down. When you're ready, push play, and we'll continue with the lesson. A box plot, also known as a box and whisker plot, looks like this. It's drawn on a number line. It uses the 5-number summary in the form of 5 dots. And then we use a box to connect the inner 3 dots with a line drawn in through the very center dot, which that represents our median. And then our extremes are on the very end. So to just kind of get you up to speed, this would be our lower extreme, our lower quartile, our median, our upper quartile, and our upper extreme. That's what all of those dots and symbols mean on this plot here. A box plot is a method of visually displaying a distribution of data values by using the median, the quartiles, and the extremes of a data set. The box here in the middle shows the middle 50% of the data. So VIC number 1, that stands for very important concept number 1. A box plot divides the data into 4 parts. Those are called quartiles. Each quartile shows 25% of the data. So I like you to think for a second about any box that you have or any rectangular part that you have. If I asked you to cut this rectangle into 4 pieces, you would make 3 cuts. 1, 2, 3. So those 3 cuts are really shown here for the lower quartile, the median, and the upper quartile. So by cutting your box in 3 places, you've created 4 quartiles. Each quartile is worth 25% of your data. It holds 25% of the data. If I group these quartiles together in any way, like if I group the first 2 together, that would be 25% plus 25%, 50% of your data. If I grouped these back 2, that would be the other 50% of the data. You could group 3 quartiles together and get 75% of the data. All of the quartiles is 100% of your data. Now, when we look at a box plot, the box plots do not need to be evenly distributed. They can be pulled one way or the other. That information is very important on telling you how evenly distributed your data is, or if it's skewed one way or the other. So all of that data is important for us, and what we're going to do today is we're really just going to focus on how to create a box and whisker plot from the 5-number summary. But later on in some other videos, you'll get some more information about how to interpret different graphs. Okay? So here we go. Problem number 1. Create a box plot of the following. So you have a set of data. The first thing you need to do in your set of data is write all the numbers in order from least to greatest. So in this case, we have 4, 5, then 7, 8, 9, 11, and 15. What you need to do after you've written all those numbers down is you need to count and make sure that you did not miss a number. So I have 1, 2, 3, 4, 5, 6, 7, 8 pieces of data. And up here I've got 1, 2, 3, 4, 5, 6, 7, 8 pieces of data. So that's really important because I would hate for you to do all that work just to realize you skipped a number. The next thing we're going to do is find our 5-number summary. First, we're going to find our median, our middle number. You can use your hands and cover up the first number and the last number until you get to the very middle. If you have 2 numbers in the middle, you're actually going to need to find the median, or I'm sorry, yeah, the average of those 2, so the very middle. Halfway between 8 and 9 is 8.5. So my median here is 8.5. The number halfway between 8 and 9. To find my lower quartile, I am not allowed to use the median that I just found. So I'm going to cover up all of my pieces of data, my median, and all my pieces of data above the median, because right now I'm going to focus my eyes and attention on the lower half of the data. I'm going to look at the lower half of the data and I'm going to find the middle number, which is halfway between 5 and 7, which is 6. So my lower quartile here is 6. I'm going to do the same thing with the upper half of the data. I'm not allowed to use my median on the upper half of the data, so you can put your hand over it, block it out. But I'm now going to find the middle number out of these 4 pieces of data. In this case, it's going to be halfway between 9 and 11, which is 10. So the upper quartile here is 10. The lower extreme is just the lowest number, which is 4. And the highest number, upper extreme, 15. Now that you have your 5-number summary, you need to create a number line. Your number line needs to include, the smallest number all the way up to the largest number. So if you look at my number line here, I don't have enough space. So I'm going to have to erase my numbers and try again. So I went from 8 to 15. But that was incorrect. I really need to have from 4 to 15. So looking at my number line, I can actually count by 2s if I want to. So let's see, that would be 2, 4, 6, 8, 10, 12, 14, 16. So that would work. 2, 4, 6, 8, 10, 12, 14, 16. If you're lucky, you'll get a number line that is already made up to match your data. Sometimes you just have to make your number line yourself. Now, a number line has to be a true number line. You cannot skip numbers. Like I skip counted, but 3 would just be halfway between 2 and 4. And 5 would just be halfway between 4 and 6. You can skip count, but I cannot go from 4 to 6 to 8.5 to 10 to 15. Because that's not how a true number line works. All right, now that we've got an accurate number line, I'm going to plot these numbers in the form of a dot above my number line. So 4, 6, 8.5. So 9 is about right there. 8.5 is going to be halfway between 8 and 9. Just use your best judgment on that. 10. And then 15 is going to be halfway between 14 and 16. All right, and then I try to make my dots all about in the same line. You're going to, what I like to do is I like to make 3 vertical lines on my inner 3 points and then connect them with a big horizontal line right there. And then just make a horizontal line, as even as you can, stretching from your box to your last extreme, your two extremes. And we've just created a box and whisker plot, also known as a box plot, for this set of data. Again, it shows you the distribution, it shows you where the quartiles are and where your 25% of your data is. There's a lot you can do with these box and whisker plots once you've got them drawn correctly. All right, let's try another one. So on this one, I went ahead and put the numbers in order, and I started to find my 5-number summary just to make this a faster process. Okay, so my lower extreme is 43. That's the smallest number. My lower quartile was 54. My median was 69. My upper quartile was 78, and my upper extreme was 94. Once you have those, you want to plot them on your number line about where they're going to be to the best of your ability. Okay, looks like I got to make this guy a little bit higher. And then, like I said, we're going to connect the inner 3 dots to make a box. And then whiskers go out to the sides. Sometimes I like to go back and make my dots nice and big so you can see where they are. And that's how you create a box and whisker plot, also known as a box plot. All right, let's look at question number 3. It says, using the box plot below, answer the questions. So in this case, you're given the box plot and you have to interpret it to answer the questions. First question is, what is the IQR? If you look back in your notes with the definition of IQR, it's the difference between the upper quartile and the lower quartile. So this was the upper quartile and the lower quartile. Difference just means subtract. So I've got 22, take away 14, for a total of 8. So my IQR is 8. B, what percent of the data is under 14? So I have to go to 14, anything under 14, and this is a percentage as my answer. Like we said before, each piece of the plot is worth 25% of the data. In this case, I'm only looking at one piece, so I'm looking at 25%. And then C, what percent of the data is 20 or more? So 20 and up. So that's one of the pieces or one of the quartiles and another. So 2/4 of the graph is worth 50%. Okay, so on your paper you've got 2 questions that you can do independently. Just press pause and do them on your own. When you're ready, push play and I'll show the answers on the screen. If you don't have the paper and you want to see the questions, here they are. Jot them down and then push pause. Try them on your own, push play when you're ready, and I'll show you the answers. Okay, here. For number 1, you have to make sure you put all your data in order from least to greatest. 72, so we're going to find the median, then we're going to find the lower quartile and the lower extreme. We're going to find the upper quartile, which is halfway between, and then the upper extreme. Okay, now that you have your 5-number summary, you're going to plot your data points. 72 is about right there, 80, 86, 99, and 100. Okay, you're going to make the box around your inner 3 points. Whiskers out to the extremes. You can make your dots a little bit bigger if you want. And there you go. There's your box and whisker. Question number 2. Using the box plot below, answer the following problems. What's the IQR? So we look, the IQR is the difference between the upper quartile, which is here, and the lower quartile. So we've got, looks like 21 here, and 6. 21, take away 6 is 15. So the IQR must be 15. What percent of the data is under 21? So here's 21, and I'm going under. So it looks like I have 1/4, 2/4, 3/4. 3/4 is worth 75%. And the last one, what percent of the data is 6 or more? So I've got 6 or more. That's 1/4, 2/4, 3/4. 75% again. All right, I hope you learned a little bit about box plots today.